Hello, this is Nas from NB Network Lessons. Good afternoon. Hope everyone's doing okay and in high spirits. My today's topic of discussion is Calculus 3, which is advanced calculus. Calculus 3, and then this is lesson number 2. Now, I've been teaching you Calculus 1, in which we introduced you what derivatives are, what functions are, and so forth. Then calculus 2, we dived into integrals, partial integrals, trigonometric functions, integrals, and so forth. Calculus 3 is something which you really use in real world. If you are planning to become a mechanical engineer, civil engineer, electrical engineer, a scientist, you will need calculus 3. Calculus 3 is where we have real application of real world, and I'm going to try to see if I can give you some examples which will show you how you can use calculus 3 in real life. So let's dive in and recap what a function is. Okay. So from your calculus 1, we had something called f of x, right? And this f of x was basically, for example, let's say f of x is equal to x square. Okay. So then in graphical form, if you have something like this, if you have x-axis and you have y-axis and you plot this, f of x is basically along y of x. So basically what you're doing is that you're plotting a graph. Okay. You're saying, let's say if x is equal to 1, okay, if function 1 would be is equal to 1, right? Then what you say is that, let's say if x is equal to 2, function of 2 is equal to 2 times 2, 4. Function of 3 is equal to 9. Function of -1 is equal to 1, because -1 square is so is also plus. So now when you draw a graph, you will get something like this. Okay. A parabola shape. All right. So now this parabola shape basically goes up to infinity on first quadrant, and in second quadrant also it goes infinity. So we discussed all that when we introduced you to calculus 1. And then we also explained you that if you want to find a slope at any given point, let's say you want to find a slope right here, right? What you do is that you draw a tangent line which barely touches this point, and you want to find slope at this. Slope is what? Its rate of change. So basically what we are trying to find by taking slope at different points is how x is, all right, how x is changing, or how the function of x is changing with respect to x. All right. So if you recall, this is basically just a revision. So if you have f of x is equal to x square, and I want to find the slope of that. All right. We explained you that what you do is that you take derivative of that, f prime of x, which denotes derivative, which is equal to 2x. By now, you should be master in derivatives. So then slope is 2 of 2x. So in other words, let's say if my x is 1 right here, what would be my slope? My slope would be 2 times 1 is equal to 2. Let's say if I want to take a slope at 4, right, where x is equal to 4, then my slope is going to be 2 times 2 is equal to, 2 times 4 is equal to 8. So basically, this right here is the equation for slope of a line at a given point. And that given point is determined by this x right here. So that was the introduction when we were dealing with just a single coordinate, just single independent variable x. But calculus 3 has a vision. It's beyond just one function. It looks at x, it looks at y, it looks at z. So if you have any anxiety, or if you are afraid, oh my god, x, y, z, three dimensions, put your fear away, because I'm going to take baby steps and teach you. So what we're going to do is, in this particular case, we are going to look at, if you see like this right here, let me draw a graph. So you have, imagine three dimensions, okay? In this way, this is my x, this is my y, and this is my z, okay? This is three dimension. So what we're going to do is, we're going to basically find, we're going to basically study function of x, y. We're going to study function of x, y, z. In calculus 1, you only had one x, single variable, independent variable. But in this particular case, we're going to look at two dimension by looking at x and y as independent variable. And then we're going to look at x, y, z as independent variable. An example of that could be, for example, you have a big room, three-dimensional room, or this room right here. And I have two huge magnets, North Pole, South Pole. Obviously, when we have huge magnets, there is going to be magnetic field around. How do I measure magnetic field at a certain point? Let's say this is a certain point in the air. This has x coordinate, this has y coordinate, z coordinate, but I want to measure magnetic field right here. I want to measure magnetic field right here because it's going to vary. So that is where three-dimensional um, variables and partial derivatives kick in. Stay tuned. I'm going to come back and we're going to have some more fun. I'm going to explain you in and out of two and three variables, functions, and partial derivatives of that. Stick with me. Share this as much as you can. And if you like the contents, go ahead and give me a like. Thank you.